So data abstraction means what? What it means? What it means? Hmm? Theory all forgotten already. Huh? What's this? What is... Oh, I think I better show you this. This background. Actually, I never updated. I forgot to update my... Yep. Yeah, you guys can see this. Alright, this one can take a look at it. Alright. Okay, this is just an explanation on a link implementation. Yeah, it will be useful. Okay. Chapter 1. There you go. Alright, so I do want you guys to check on the Padlet. Okay, Padlet got, I've scribbled some information here that you can use. Alright. Hide the implementation inside. What did I wrote? I still don't know what I wrote. Inside the class. Okay. Preventing unauthorized access. Okay. So I've scribbled a lot of stuff here, so you can just take a look at it and read through. Okay, additional info. All right. So that will be very helpful for you in order to answer theory questions. Okay. Yeah. My handwriting is a bit weird also, kan? I myself cannot read already. But I can figure out it's my handwriting. But well, best of luck for you guys then. Okay. Okay, so do check. I have explain a little bit here. Okay. So that will able to give you some information. Okay. You must explain how or what is data structure and encapsulation. Okay. Hey, what time's the class? You're my student or not, Christopher? You are not. What are you doing here? At corner. Oh my God, you gotta pay me, man. We're already hungry, isn't it? Hungry and tired from this morning, huh? Some of you have? Some more 10 o'clock. Some more. Until 10. Best of luck. Okay. Now the second question B, I want you guys to take a look at it now. Okay. Now, if you take a look at this question, what collection would you, ADT collection, would you recommend for this palindrome? This is why I say you have to go through array just in case. All right, you have to write coding. All right, if you feel writing coding in array is easier, just in case. Okay. Now, palindrome. Reading a word, sentence, or phrases forward or backward. Okay. How? What do you want to use? List, stack, queue? Which one do you want to use? What do you think? The rest of you, what do you think? Q? Can I use Q? This one is we want to read, alright, backward in a reverse manner, right? Okay, so palindrome works like this. Let's say, madam, I want to see whether we read forward and backward are the same. So fast is to use stack because I can read it in a reverse way, correct? Okay, for this question, let's see. Let's look at the questions, okay? Propose appropriate ADT collection for checking. Alright, so now what? What I'm gonna say? 4 marks only. Okay? I'm gonna say stack is most appropriate. Okay? Why? Why it's most appropriate? Okay? So you have to explain that. Alright? Explain how stack works. Alright? Use the word last in, first out. Okay? These are the keywords you must use. Alright? Last word in, and then show how. They already given sample. Right a bit. Add can. Then you're gonna add MA. Then you're gonna add MAD. MADA. MADAM. Correct? So this is going to be a push method. Okay? Then for pop, alright, so what we're going to do for pop? So we're going to pop M first. Then MADA. Then you just, indicate A. A is popped. Now D is popped. MA. A is popped. M. And M is popped. So now it's null, nothing there. Alright, so you can illustrate this. Okay, show illustration. Alright, show how. Okay, so illustrate. Alright, 4 marks now, but still, if you can illustrate, you can illustrate a little bit, show how it works. Okay, explain why stack can be used because it's the first in, so you can say it's a linear collection. Alright, so first in, first out, follows the first in, first out rules. So where we can insert our data, alright, in one way, then we can read it in the other way, so that data will be reversed. Now by checking the first the original data with the data we read from the stack, if they are equal, alright, so then you have to explain if the original data is equal to the data we read or pop from the stack is equal, then alright, then it's a palindrome. Okay, so here we can set. Alright, can? Yes or no? So here the concept, you must get it from chapter 1. Okay, the concept we must get it from chapter 1. If you don't understand, then you cannot apply what to use. Okay, Cam? Okay. Second part is explain two cooperation. Stack two cooperation. What is this? Basic operation. What is it? Add and remove, right? Add and remove. For stack, add and remove will be what? Push and pop. Alright. What they say? Write ADT. Do you write ADT specification? Do you write ADT specification here? Do you implement in this question? No implementation, thank God. Just explain only. So you just simply explain now what is push, what is pop. Alright? Boleh? Hannah? Okay, this one we did today. Alright. Okay, now let's move on. Alright, so last one. Okay, chapter 6. Okay, now chapter 6, yes, it's involved in sorting and searching. Alright, it is involved here. Okay, sorting and searching. Alright, but for our exams, okay, you can study by itself. Alright, okay, so for chapter 6. Okay, chapter 1, 2, 4, 5, any questions? Okay, alright, so for today, last one now. Okay, chapter 6, recursive. Good. Alright, recursive. Alright, basically you have to write a code. Alright, or box trace some algorithm. Okay, write a code, recursive code, or you have to do a box trace. Okay, write a code, it could be a rewrite a code also can. Alright, so for your area, alright, so let's concentrate on box tracing. Okay, do read through all how to. Now actually you need to understand how recursive works in order for you to trace it. Alright, so you really have to check how the recursive code works. Okay, so the main idea for recursive code is, okay, so let's say if you have a method. Alright, so this is your recursive method. For example, okay, recursive method which has some parameters, right? So open, close. Alright, so here you have to call the recursive method with some input. Right, you must have if, stopping, case. Alright, okay? So this is the concept of it. Okay, basically this will be the concept. Okay, now how to box trace it. Okay, how to box trace this. Now, box trace, draw a box. in cascading, waterfallish look. Alright? Can? Now use an arrow down for recursive call and arrow up to return the argument value, return the results. Okay, so this is call, this is the results. Okay. Now for exam, draw neatly lah. Use the entire page. Don't draw small. Don't draw haphazardly. Draw neatly. Okay. So when we see a neat drawing, even there is an error, we tak nampak. Alright, because the drawing looks so neat. Okay. So we also while marking, very nice. Tapalah. Like that, give 4 marks. Okay. So just be careful lah. Okay. Now next is you must have value. Okay, argument value, and then you must have your recursive call. Okay, so this recursive call actually will have the value reduced and then recursive call to make the problem smaller, the value smaller. Alright, then you might have some kind of return one. This return based on stopping case. Alright, your stopping case, you stop already, then you return the stopping case value out. Alright, can? Okay, this one, it's not really this one have to rewrite. This one is answer from chapter 6. This one is straight from your practical question. This one to rewrite the code. Okay. Oh, write the output, sorry. This one write the output, then you have to rewrite the code. Okay. This one is your sample code largely. Exactly from the sample code. Okay, chapter 6. This one also dividing by half is a sample code. Check on the sample code. Now let me find something else. Okay. It's the same. I think I remember doing this. question. Yeah, this one. Remember we did this? This one? Yeah. So this one also, it's in your Padlet now. You can check on the Padlet. Okay. So you need to know how to read your recursive coding. So based on the coding only, you can draw the trace box. Okay. So check recursive code by itself, not under sorting or searching lah. Alright. You want me to go through this question again? Alright, so let's see. This one is, I think, if I'm not mistaken, first question, first paper, right? Is it? Yeah. Yeah, okay, the first paper. Alright, so we have to do a trace box. Alright. Okay, let's see. Okay, so now let's take a look at this code here. Okay. Now we will see that we are sending a array value 1 to 5. We want to find out the sums. 1 plus 2 plus 3 plus 4 plus 5. Right? So how are we going to find out the sum? Alright? So I have a stopping case when my length, there's a slight error here. Array length and array length is the same lah. Okay? So if the length is the size of the array, okay? So when is less or equal to 1, we return 0. Okay, so this is the stopping case lah. This is where you stop. Okay, so next we have our we have a recursive call. You see this one, recursive call here. Now what are we sending? We are sending the array, that means list 1, 2, 3, 4, 5, and the length minus 1, alright, and then plus array length minus 1. So this is what we are sending in. Alright, so if we check, alright, my code here, I open here first one. Okay. What's this okay, here. Alright, so the first is array length. Alright, array length is 5. Alright, that's our argument. So let's check. My array length is 1, 2, 3, 4, 5. Right? Okay, so that's my value. My recursive call is array, and what we have? Length minus 1. Alright? So what is the length? 5, isn't it? 5 minus 1 is 4. 5 minus 1 is 4. Alright? So what I'm doing, I am calling. This is my recursive call. Alright, this is my recursive call. Now, it's over here, over there. You see this part here? what is the parameter again? Array and the length. For sum, find sum, we have to send a parameter array and the length. Okay, so that's what we see here, array and the length. Okay, on top of that we also will add with array for index 4. Array index 4, okay, here, make it clear for you. You see array length minus 1. So we are reading a value at index 4, fourth index. Okay? Okay? Understand this part? Okay, I'm not getting any value, I'm just drawing the box. Okay? So now recursive call find sum array and array length is 4. My array length is for the next one. Recursive call array length is 4. Do you understand? Got it done? Now we have to do the recursive call again here. So sum, find sum array, be sending the array, but here array length minus 1, so that will be 3. So here is array index 3, correct? Understood? Now for the next recursive call, because my array length is not 0 yet, okay, only when it's less or equal to 0 it will return 0. So we have to break it down into smaller problem again. So this time it's going to be array length is equal to 3. So we need to find out what is the sum. Find sum array. 3 minus 1 is 2 plus array index 2. Then find what is length. Array length is 2. Find sum array length. 2 minus 1 is 1 plus array index 1. So now array length is 1. So still we have to do the recursive call array, find sum array 0. My length now is array length is equal to 0. So I already reached stopping case, correct? So now I already reached stopping case, I will return 0. Now the green color is the value. I'm returning 0. Correct? So this, the entire thing here, okay, this part here is 0. It's returning value 0 plus array index 0. What I have? Array index 0. 0 is here, right? Index 0, 1. So 0 plus 1. So now what I have to return 1. So this part here, this here, find sum array, comma 1 is, the value for this is 1. Okay? Plus, now what is array index 1? Index 1 got 2, right? Right or not? Okay? So 1 plus 2 is 3. So I return 3 to the recursive call. Alright, and array index 2 is 3, so 3 plus 3 is 6, correct? Then I return it to this, find sum array, comma 3, so this value is 6 plus array 3, you can see array 3 is 4, 6 plus 4 is 10. Then I return it here. As you can see here is 10 plus array 4. Array 4 is 5. So 10 plus 4 is 15. So 15 is the answer. Is that correct? 1 plus 2 plus 3 plus 4 plus 5, 10. Yeah? You understand? So this is what you have to write. Okay? Easy? 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 Make it easy, okay? Look for some other questions and do the trace box. Okay, maybe I can take a look at it. Alright? Okay? Understood? Okay, yeah? Look at the stopping case. Stopping case will produce the value, the final result. You just plug it in. Alright, Ken? Alright? Okay, so chapter 1, 2, concept. Okay, it is important for throughout the entire course. Okay, chapter 3, just look through, because you may want to use it for explanation. Alright, chapter 4, 5, study together. Alright, and as I said, you may require array, so don't spend so much time, but still go through it. Link implementation, burn it, take the ash, drink it up or something, or run around the fire, so make sure it goes into your head. Okay, link implementation. Chapter 6, go through coding, and then see how you can box trace the coding recursive. Alright, chapter 7 can drop, chapter 3 can drop. Chapter 7 can drop without even looking at it. Okay, tendang level out. It's okay. Okay, chapter 3, look a bit, see a bit. Okay, now for next revision, alright, okay, now if you see the way that I boxed it, alright, the way I boxed the topics, and you already know what are the questions. Okay, so for chapter 8, 9 and 10, I'll go through next class. I see you. If it's possible, do some work on it. So bring some answer, then we can discuss in class. Okay, what do you do? Let's say 5 of you study together, or you just decide one paper, one question you do, another paper, another question you do. Alright, bring it for class, we discuss. Okay, anything, then you guys can share it now, answer, so can study smartly. Right? Okay, okay. Alright, any other questions? Okay, so I see A's. Do I see A's?